solving radical equations. So the steps for solving radical equations are to first isolate the radical. So normally in solving an equation, your goal is to isolate the variable. Well, in order to do that, we first have to isolate the radical. And then we'll cancel the radical with an appropriate power. So if we're taking a square root, we'll cancel it by squaring. If we're taking a fourth root, we'll cancel by raising it to the fourth, and so on. Whatever root you're taking, you raise it to that power to cancel it. And then simplify and solve, and depending on what it looks like once you raise both sides to the appropriate power, the simplifying and solving can be fairly straightforward, or it can take a quadratic equation to solve. So we'll look at some of the simple ones first. This being Valentine's Day, that you either should be watching it or will be working on it. I'm working with the reds and pinks, but I knew the pink was hard to read, so I did the examples in black. So this says section 2, solving. Example 1, solve each radical equation. So in example A, we already have our radical isolated. We've got the square root, and granted there's stuff under it, but it's the only thing on one side is the radical. So I'm going to cancel that by squaring it because it's a square root, so that's how we cancel square roots. So again, the square root and the square cancel, leaving me with x minus 9. 5 squared gives me 25. Adding 9 to both sides, I get a simple, straightforward equation for our first example. We're warming you up. Second example, we have a radical on both sides of the equal sign. Now we have the radical on the right-hand side isolated, but not the one on the left-hand side. If I think about dividing both sides by 2, then I'm going to have the radical on the left-hand side isolated, but not the radical on the right-hand side. Because I have no option, I'm going to square both sides and cancel the radical. Now on this side, I'm not just squaring the x, I'm squaring the 2 as well. So on the left-hand side, I get 4, and then the squared and the square cancel, x. On the right-hand side, the radical and the square cancel, leaving me with x plus 8. Subtracting x from both sides and dividing by 3, I get my solution. 2 more examples, short lesson today. See, we've already got the radical isolated, so I'm going to square both sides. Again, this one I am squaring the entire right-hand side. So when I square my left-hand side, it cancels the radical. And on the right-hand side, be careful that you don't fall into the trap of squaring just your x and missing the 2, and squaring your 3, or if you catch that you need to square the 2, just squaring the 2x and just squaring the 3. Remember, squaring means multiply it by itself. So when we multiply a binomial by itself, we need to distribute. So the 2x times 2x gives us 4x squared. And then I do this at the same time. 6x plus 6x gives me 12x. And 3 times 3 gives me 9. Now whenever you have an equation with a square and a regular x, it's a quadratic equation. You have to set it equal to 0 before you can solve. So I'm going to rearrange this because I like to see my squares on the right-hand side. So I'm really going to be subtracting the 15x and subtracting the 10, but I'm going to write it with my 4x squared first. So 12x minus 15x is negative 3x, and 9 minus 10 is negative 1. This is the AC method in order to check to see if it factors. So I'm thinking about what multiplies to negative 4 and adds to negative 3. One of the times in the videos I factored wrong, so I'm going to be a little more careful this time instead of trying to keep track of it all in my head. So we've got negative 4 times a positive 1, and that checks for a negative 3 as well. Now with the AC method, you have to factor by grouping. So it becomes minus 4x plus 1x. First 2 terms, and let me show my work just in case. So I'm looking at the first 2 terms, I can factor out 4x. Now be careful on this because factoring is division. That 4x doesn't disappear. We're not canceling it by adding it, and then it cancels to 0. 4x divided by 4x is 1. Second 2 terms, my GCF is 1. And for factor by grouping, sometimes it's helpful to go ahead and pull that out. Let's see if I can't give myself a little bit more room to work here. So then the GCF is x minus 1. And then I set each piece equal to 0. So either x equals 1 or subtracting 1 and dividing by 4, x equals negative 1/4. Now remembering that we've been looking at the domain of radical functions, not necessarily all of our answers will work. So you may want to check this into the original equation. Now quickly thinking about the 1, 15 plus 10 is 25, square root of that is 5. Over on the other side, 2 plus 3 is 5, so that does check. Take me a little bit more work to check the other one. But if we do 15 times negative 1/4, that is less than 10, so we would still get a positive value under the radical. So that does have a chance of working out as well. If you want to check that a little bit more accurately, you can do that. And our last one. So on this one, remember, the 1/3 power is the same thing as a cube root. You don't have to write it in radical form in order to solve this, but for some of you, because you are so much more familiar with the radical notation, it might be helpful. So what I'll do is I'll do this example two ways, one with the rational exponent and one with the radical notation, so everyone can see the method they're comfortable with. Now this one, because I don't have a radical or a rational exponent on both sides, I'm going to go ahead and divide that too and isolate my variable first. And I'm so used to teaching Algebra 1 that I was going to show my work, but for you guys I show the result of my work. So we'll look at this with rational form first. So dividing both sides by 2, and then to cancel that 1/3 power, I'm going to raise both sides to the 3rd power. So remember, the power of a power rule is multiply. Well, 1/3 times 3 is 1, so they cancel. 2 cubed is 8, and subtracting 1 from both sides, I get 7. Now for those of you that like the radical form, you could rewrite this as the cube root of x plus 1. The steps are exactly the same. Divide both sides by 2. Cube both sides to cancel the cube root. And subtract 1. That is it. Have a great evening.